Hello, my name is Maria from mathmammoth.com. In this lesson we are going to be graphing proportional relationships. But first, let's review what is a proportional relationship between two variables. The basic idea is that whenever one variable changes, the other also changes, but in what manner? It changes at the same rate, proportionally. For example, I've told you this before, that if one variable doubles, the other one doubles also. If one variable is 3 times itself, then the other one also is 3 times itself. Or if one variable is halved, the other one also, its value is halved, and so on. We can also look at unit rate. We could calculate the unit rate using this pair of values, or we could calculate the unit rate using these two, or these two, etc. And if every time we get the same unit rate, no matter which two we use to calculate it, then it is a proportional relationship. So for example, from here, if something costs $5.50 for 5 kilograms, then the unit rate is the cost per 1 kilogram, so that is $1.10 per kilogram. And so for example here, $22.20 kilograms, 22 divided by 20 would be the same, 1.10 per kilogram. Here also, and here also, and here and here. This is indeed a proportional relationship. And this is the same idea as each of these pairs being in the same ratio or rate. Each one of these two values is a rate. This is a rate, this is a rate, okay? $22 to 20 kilograms, that's a rate. $27.50 to 25 kilograms, that's another rate. And each one of these rates are equivalent. And then it is a proportional relationship. Okay, let's read together this little review box. When two quantities are in a proportional relationship or in direct variation, that's another way of saying the same thing, direct variation or proportional. Then these three things are true. First, each rate formed by the quantities is equivalent to any other rate of the quantities. Number 2, the equation relating the two quantities is of this form, y equals mx, and y and x are the variables, and then m is a constant. This constant is called the constant of proportionality, and it's also the unit rate. And then number 3, when you plot this, the graph is a straight line that goes through the origin. Okay, so this is just review from earlier grades. Alright, here's a simple exercise for us to solve. In a direct variation, when x is 12, then y is 10. Let's write an equation for this proportional relationship. We already told that our variables are called x and y, and the equation in general is of this form. It's always of the form y equals mx when there's a proportional relationship. And so we just need to find out the value of m. And we know that when x is 12, y is 10. So we can plug those two values in to this equation. So we get y is 10, 10 equals m times 12. And from here, to solve for m, we divide both sides by 12. So m equals 10 over 12, which we can also simplify to 5 over 6. And so the equation would be, if I have space, y equals 5 over 6 times x. Now we're going to graph it in this grid, and it's going to be a line through the origin, okay? So it's going to go through here. So we only need to find one other point to be able to then graph it. We could take any point, like when x is 1, then y would be 5/6, okay? But actually it will be very handy to use a certain number here so that we get a grid point. If I put x equals 6 over here, then 6 is cancelled and y is 5. It's 6 and 5. So a line through here will be the graph. I'm gonna have to eyeball it so it may not be totally straight line. I apologize. Something like that. And then lastly, what is x when y is 17? Okay. We have this equation. When y is 17, Let's put it here. 17 equals 5/6 times x. So now what? Multiply by 6. We get 102 equals, and over here 6 times 5/6, it's just 5x. Divide by 5. And x equals 102 over 5. If we don't want to leave it as a fraction, we could give it as a decimal or a mixed number. I'm just running out of space. So 100 divided by 5 is 20. And then 2 divided by 5 is 0.4. So 20.4 is the value of x. Okay, lastly, we're going to look at this graph, which shows a distance that the car has covered over time. Think about each of these questions yourself first, okay? Are the quantities time and distance proportional? We can see it right from the graph. Because when two quantities are proportional, then the graph is a straight line through the origin. So yes, in this case, they are proportional. What is the car's speed? That we can tell by reading from the graph just one point. Any point will actually work. For example, I could take this point at 30 minutes over here, whatever that is, or at 60 minutes, that's a handy point, right? 60 minutes, it has covered 75 kilometers. 60 minutes is 1 hour, so we get 75 kilometers per hour. Now, this horizontal axis is actually in minutes. So you could give an answer as so many kilometers per minute. It would be correct since the question didn't specify. But this is customary, right? This is kind of what you would usually expect. Kilometers per hour, not kilometers per minute. What is the unit rate? Okay, for that we need the quantity per 1. This here, the distance per 1 unit of time. So since this is in minutes, for the unit rate we do need to answer what is the distance that it covers in 1 minute. We can't really read it from the graph though. It would be 7.5 minutes, it would be somewhere way over there. We can't read it. We would have to calculate it. And we can do so by taking any point, any two values, such as the 75 and the 60, and dividing. So it is, this here is the unit rate. Both of these are divisible by 15. This is 5 times 15, this is 4 times, so we get 5 over 4 kilometers per minute. And this is 1 1/4, so as a decimal, 1.25 kilometers per minute. That is the unit rate. What is the slope of the line? Slope has to do with the steepness of the line, and it is the same concept as the rate of change, which you have already learned about. And the rate of change, we looked at, okay, how much did the distance change over time? And we get the same amounts, 75 kilometers in 60 minutes. The slope is the same, this 1.25 kilometers per minute. The unit rate and slope are the same. Then write an equation for the graph. What is the general form of this equation when it's a proportional relationship? Y equals mx. Okay? This time, instead of y and x, we have two other variables, two other letters to use, t and d. T is the independent variable and d is the dependent. So instead of y equals mx, it is d equals some number times t. What number? That's pretty easy. It's the unit rate. We already calculated it. So we just grab it from there, 1.25. Lastly, continuing with the same speed, how long will this car take to travel 250 kilometers? This is a distance, right? D, distance. So we're given the value of d, and we have an equation that relates d and t. We're asked for t. Okay, I'm gonna move down. So we will use this equation and put 250 kilometers in place of d. And now divide both sides by 1.25. If I divide it by 125, this would be exactly 2. But since it is a decimal, I will actually get 200. Now, what unit is this 200 in? Our equation had to do with minutes and kilometers. So this is minutes now. It's time. So 200 minutes. So that would be about, 3 hours. 3 hours is 180 minutes and then 20 minutes after that. So that's long how this car will take to travel 250 kilometers at this speed, which was 75 kilometers per hour. Alright, we're all done with this lesson. I hope it was helpful.